Ever wondered why a pencil appears to bend when you dip it in water? This is a simple example of how light behaves differently when it travels from one medium to another. As light moves from air into water, it slows down and changes direction, creating a seemingly bent pencil. This is no magic trick, but a fundamental property of light at play: refraction. This bending of light is what we call refraction, and the degree to which light bends or refracts is what we refer to as the refractive index. So, what exactly is refractive index? Well, let's break it down. Think of refractive index as a sort of speed limit for light. It's a dimensionless number, meaning it has no units attached to it, that tells us how fast light can travel through a material. If we're talking about a vacuum, where there's absolutely nothing to slow light down, the refractive index is 1, but when light enters a different medium, say a glass of water or a diamond, it slows down. That's because these mediums are denser than a vacuum, and it takes more effort for light to move through them. But that's not all. Refractive index also gives us an idea of how much a light path is bent or refracted when it enters a new medium. This is what causes the bent stick illusion when you place a stick in water. The light coming from the stick is refracted or bent as it travels from the water to your eyes. So the stick appears to be at a different position than it actually is. Fascinating, isn't it? To tie it all together, we can say that the refractive index provides a twofold understanding. It tells us how much light slows down when it moves from one medium to another, and it also shows how much that light's path is bent in the process. Simply put, the refractive index tells us how much light slows down and bends when it enters a different medium. Now that we've got a grasp on what refractive index is, let's go over the key points. The refractive index, in essence, is a measure of how light, or any other wave, interacts with a specific substance. It tells us two crucial things. First, it measures the speed of light in a material. Light travels slower in a substance with a higher refractive index as compared to one with a lower index. Second, it tells us about the bending of light rays, or refraction. The higher the refractive index, the more the light bends when it enters the material. This bending is what causes phenomena like the apparent bending of a pencil in water, or the dispersion of white light into a rainbow. So, the next time you see a pencil bending in water, or a rainbow after a storm, remember, it's all about the refractive index.